Let us see the question 14, students. If a sec theta plus b tan theta is equal to n and b sec theta plus a tan theta is equal to n, prove that a square plus n square is equal to b square plus m square. So now student, let us start how can we solve this example. So here students, we have to solve, we have to prove out that a square plus n square is equal to b square plus m square. So that means the given, in the given we have to here square, okay, squaring the equation. So here first equation is that the a sec theta plus b tan theta is equal to n, and the next one, that is the b sec theta plus a tan theta is equal to n. So here squaring on both the sides, squaring on both the sides, squaring on both the sides. So here a sec theta plus b tan theta is equal to, square of a sec theta plus b tan theta is equal to m square. So square of this, a square sec square theta plus 2ab sec theta tan theta plus b square tan square theta is equal to m square. Okay students, so now this is a value of m square. Now here also in this part students, we have to also square on both the sides. So we have b sec theta plus a tan theta whole bracket square is equal to n square. So here b square sec square theta plus 2ab sec theta tan theta plus a square tan square theta is equal to n square. Okay, so students, this one that I call this as a first equation and this one as a second equation. So now here subtracting equation, subtract equation 1 and 2. So here I subtract m square minus n square. So m square is this one, a square sec square theta plus 2ab sec theta multiply tan theta plus b square tan square theta minus n square is this one. So b square sec square theta plus 2ab sec theta multiply tan theta plus a square tan square theta. So now remove the bracket, that's why we can simplify. It will be simplified. So here a square sec square theta plus 2ab sec theta multiply tan theta plus b square tan square theta minus b square sec square theta minus 2ab sec theta tan theta minus a square tan square theta. So now here student, see here is the plus 2ab sec theta tan theta and here minus 2ab sec theta tan theta. So it will get cancelled. Okay. So now here the remaining factors are a square sec square theta plus b square tan square theta minus b square sec square theta minus a square tan square theta. Okay, now I arrange the terms. I arrange the terms this way, students. Here I write m square minus n square is equal to, that is first I write a square sec square theta, a square sec square theta, and minus b square sec square theta. Then I write the third term as b square plus b square tan square theta, okay, minus a square tan square theta. Okay, then here see, take these two terms first, then sec square theta is common in between two, so sec square theta minus a square upon minus a square minus b square. Then here take these two terms, so plus, and here common is tan square theta, and in the bracket we write b square minus a square. Okay students, now here is the a square minus b square, and here is the b square minus a square. So here we can change the sign. So here sec square theta a square minus b square. I here place the sign minus, and then tan square theta multiply a square minus b square. So here students, a square minus b square is a common. So we write a square minus b square as common, and in the bracket we can write sec square theta minus tan square theta. So now here we know the third identity students, that is the 1 plus tan square theta is equal to 1. So here students, that is 1 plus tan square theta is equal to sec square theta, and that means the tan square theta minus sec square theta is equal to 1. Okay, is equal to minus 1 students. So now here sec square theta minus tan square theta, that means it will be 1. So a square minus b square, and the answer of is 1. So here m square minus a square. So now rearrange the term as we want, that is a square plus m square. That is a square plus here I here write a square plus n square, and here m square plus b square. Then again change the position. So a square plus n square is equal to m square plus b square. Okay, so such a way we can prove this theorem. Okay, so example 15 students, use the identity sin square a plus cos square a is equal to 1 to prove that tan square a plus 1 is equal to sec square a. Hence, find the value of tan a, where sec a is equal to 5 upon 3 and where a is an acute angle. Okay students, so here the given are the two identities, sin square a plus cos square a is equal to 1 and the 1 plus tan square a is equal to sec square a. So first we use the second identity, that is tan square a plus 1 is equal to sec square a. So now here students, in this identity LHS is equal to tan square a plus 1. So now here that sin square a upon cos square a, we can write the tan square a as sin square a plus upon cos square a plus 1. Okay, so now here we can write here cross multiplication sin square a plus cos square a upon cos square a. So here sin square a plus cos square a, that means the given is the 1. Okay, this is the first identity of it. So we put this value here. So 1 upon cos square a. So we know that the 1 upon cos A, that means the sec A. So here 1 upon cos square A means the sec square A. So here students, that LHS is equal to sec square A, which is equal to RHS. So LHS is equal to RHS, and therefore we can say that the tan square A plus 1 is equal to sec square A. Okay. So this we prove out. Now here the value of the sec A, that the value of sec A is equal to 5 upon 3 students. Okay. So now here we write that as a tan square A plus 1 is equal to sec square A. So here student, that here sec square A, the sec A, the value of sec A, that is the 5 upon 3. So sec 5 upon 3 whole bracket square. Okay, students, here sec 5 upon 3, that means the 5 upon 3 whole bracket square. Okay, tan square A plus 1 is equal to 5 upon 3 whole bracket square. So now here tan square A plus 1 is equal to 25 upon 9, and that means tan square A is equal to 25 upon 9 minus 1, that means 25 minus 9 upon 9, and that means 16 upon 9. So here the value of tan A, that tan A is equal to 4 upon 3. So here tan A is equal to 4 upon 3. Okay, and for the A is an acute angle. Example students, prove that root sec A minus 1 upon sec A plus 1 plus square root sec A plus 1 upon sec A minus 1 is equal to 2 cosec A. So let us start to solve it. First here we write that square root sec A minus 1 upon sec A plus 1 plus square root sec A plus 1 upon sec A minus 1. This is the LHS, left hand side. So here I write LHS. So I try to get the answer as LHS is equal to RHS. Okay. So that's why LHS, right? And then I simplify this sec A as 1 upon cos A, then minus 1 upon cos A plus 1. Here plus in the square root 1 upon cos A plus 1 upon cos A minus 1. Then again simplify it by cross multiplication. Then here 1 minus cos A upon cos A divided by 1 plus cos A upon cos A plus here 1 plus cos A upon cos A upon 1 minus cos A upon cos A. Okay, I simplify it by cross multiplication students. Then here also simplify further. Then 1 minus cos A upon cos A, that is the numerator, and the denominator reciprocally cos A upon 1 plus cos A. So here cos A get cancelled. So in the square root 1 minus cos A upon 1 plus cos A. And here students, that is again simplify this 1 plus cos A upon cos A, this is the numerator, and then denominator write in the reciprocal form. Then cos A upon 1 minus cos A. So plus here cos A get cancelled. So 1 plus cos A upon 1 minus cos A. Okay students. So now here further I simplify this as LHS is equal to in the square root 1 minus cos A upon square root 1 plus cos A plus here in the square root 1 plus cos A upon square root 1 minus cos A. Then here the denominator are different, so here cross multiply. So in the square root 1 minus cos A multiply square root 1 minus cos A plus in the square root 1 plus cos A in the second bracket square root 1 plus cos A divided by in the first bracket 1 plus cos A, in the second bracket in the square root 1 minus cos A. Then here see students, both the brackets are same, so that means square root of 1 minus cos A and whole bracket square. Here plus, here also both the brackets are same, so 1 plus in the square root 1 plus cos A whole bracket square divided by. So now here it is in the 1 plus cos A and 1 minus cos A. That means the A plus B and A minus B form. So here we can write that is in the square root 1 minus cos square A. So now here students, this simplify we simplify this, then 1 minus cos A square of this, that means 1 minus cos A plus here also square of square root 1 plus cos A, that means 1 plus cos A. Now here students, what about this? This is the sin square A plus cos square A is equal to 1. So that means here sin square A is equal to 1 minus cos square A. So here we can write that sin A is equal to in the square root 1 minus cos square A. So replace sin A here. So now here students 1 plus 1 that means the 2 and minus cos A plus cos A that means the 0. So 2 upon sin A. So now here we separate out that 2 multiply 1 upon sin A. That means here 2 multiply 1 upon sin A, that means cosec A. So now here that 2 cosec A means the value of RHS. So here students, the LHS is equal to RHS. Okay. So this way we can prove out.